Delving deep into scikit-learn's discriminant analysis. The sklearn discriminant analysis module offers powerful tools for classification and dimensionality reduction based on statistical principles. It provides implementations of three primary methods. 1. Linear discriminant analysis (LDA). Core principle LDA is a supervised learning technique aiming to find the linear combinations of features that best separate classes. It assumes a Gaussian distribution for each class and seeks to maximize the distance between class means while minimizing the variance within each class. Implementation. The sklearn discriminant analysis linear discriminant analysis class provides the following functionality. Fit X. Y trains the model on the data X and labels Y. It calculates the mean and covariance matrices for each class. Predict X predicts the class label for new data X using the learned model. Predict Prob X returns the probability of belonging to each class for new data X. Transform X projects the data X onto the discriminant axes, reducing dimensionality while preserving class separability. Applications. Classification. LDA excels in multi-class problems where classes are well separated and data has a Gaussian distribution. Dimensionality reduction. LDA can reduce the number of features while retaining information relevant to class discrimination. Feature selection. LDA can identify features that are most discriminatory for the target variable. Advantages. Simple and computationally efficient. Robust to outliers and can handle high-dimensional data. Provides interpretable decision boundaries. Disadvantages. Assumes a Gaussian distribution, which might not always hold true. Can be sensitive to imbalanced datasets. May not perform well when classes overlap significantly. 2. Quadratic discriminant analysis (QDA). Core principle. QDA relaxes the assumption of a shared covariance matrix for all classes made by LDA. It allows each class to have its own covariance matrix, resulting in quadratic decision boundaries. Implementation. The sklearn discriminant analysis quadratic discriminant analysis class provides similar functionality as LDA, but it fits a separate covariance matrix for each class. Applications. Classification. QDA is suitable when classes have different shapes and variances, making it more flexible than LDA. Feature selection. QDA can identify features that are most discriminatory for each class individually. Advantages. More flexible than LDA in handling nonlinear class boundaries. Can be more accurate than LDA in some cases. Disadvantages. Requires more data than LDA for accurate model estimation. Can be computationally expensive for large datasets. Decision boundaries can be more complex and harder to interpret. 3. Linear discriminant analysis for dimensionality reduction (LDA). Core principle. LDA can be used for dimensionality reduction, projecting the data onto a lower dimensional subspace while preserving information relevant to class discrimination. Implementation. The sklearn discriminant analysis linear discriminant analysis class provides the transform method for this purpose. Applications. Visualization. LDA can project high-dimensional data onto a 2D or 3D space for easier visualization of class separation. Feature selection. LDA can help identify features that are most important for class discrimination. Preprocessing. For other models, LDA can reduce the dimensionality of the data, potentially improving the performance of other machine learning models. Advantages. Efficient and interpretable method for dimensionality reduction. Can be used for visualization and feature selection. Disadvantages. Assumes a Gaussian distribution and may not work well for nonlinear data. Important considerations and tips. Data preprocessing. It's crucial to scale or standardize the data before applying discriminant analysis to prevent features with larger scales from dominating the analysis. Class imbalance. For imbalanced datasets, consider using techniques like oversampling, undersampling, or class weights to improve model performance. Model selection. Compare LDA and QDA using cross-validation to determine which method performs better for your specific dataset. Visualization. Visualize the decision boundaries of the model to understand how it separates the classes and identify potential areas for improvement. Example: Python. From sklearn, discriminant analysis. Import linear discriminant analysis. From sklearn, datasets. Import load iris. From sklearn, model selection. Import train test split. Load the iris dataset. Iris. Load iris. X iris. Data. Y iris. Target. Split the data into training and testing sets. X train. X test. Y train. Y test. Train test split X. Y. Test size 0.2. Random state 42. Create and train the LDA model. LDA linear discriminant analysis. LDA. Fit X train. Y train. Predict the labels for the test set. YPRED LDA. Predict X test. Evaluate the model's performance. From sklearn, metrics. Import accuracy score. Accuracy score test. YPRED. Printf accuracy. This code snippet demonstrates how to train an LDA model on the iris dataset and evaluate its performance. You can adapt this example to explore the other features of the sklearn discriminant analysis module and apply it to your own datasets. By understanding the core principles, implementation details, and considerations of sklearn's discriminant analysis, you can leverage these powerful techniques for effective classification, dimensionality reduction, and feature selection in your machine learning projects.